get started with unit standard 25704. Task 1, the 90-degree equal size pipe penetration. You're going to need drawing instruments similar to what I've got here, and you're going to need some set squares and T-squares. I'm using the same student drawing board as you'll be using. So what we've got is, we've basically got this sort of thing here. It's a 90-degree pipe, both pipes are the same diameter. The size in the assessment will be slightly different. So these are my dimensions here. Now obviously it's too big to fit on one sheet of paper, so we've got to scale it down. I've scaled mine down 1 to 3. Depending on the size of yours, you may scale it down 1 to 4, 1 to 5, just so it fits on the page. The easy way to work out the scale is 1 to 3. If you've got model cars, Matchbox toys, they're like 1 to 32, 1 to 40. Radio controlled cars are 1 to 12 and things like that. So it means 1/12 of the size. So this is 1/3 of the real size. We also talk about mean diameter, so you'll have to do some maths to work out what the mean diameter is. And the mean diameter is actually the middle of the thickness of our material. So it's quite easily worked out with a simple calculation here. Mean diameter equals the outside diameter minus 1 thickness. So I've already worked out the maths that I need to do. Mine's all pretty straightforward, and here it is here. So this is what your finished item should look like. I've developed out both this portion here and the top portion here. So there's the base. This represents the hole cut in it. The blue line is one way of doing it, and the red line is another way of doing it. As a welder, we would prefer it done with a blue line, so we only have a short area to weld. In other situations, you may want to weld the full length and have the hole in the middle. Here is the top piece, and that is the flat sheet of material ready to roll up and to make our item to go on the top. Firstly, we have to draw this image. We'll start at the bottom, and we're going to start off by drawing a center line. As my dimensions are different to yours, I'll be working to my scaled down dimensions now. My scaled down dimensions are 60 millimeters diameter, so I need half that, 30 millimeters. So I have set my compass at 30 millimeters. I've drawn my center line in, and I'm just going to draw a circle here. That will give me the top and bottom of my cylinder. And we can draw our pipe in. Now this doesn't have a specified length, but I need at least 60 millimeters, so let's make it, I don't know, we'll make it 110 millimeters long. So this length doesn't matter, and we have to find the middle of that. And using our instruments, there's the middle of our pipe, and as we know, it is the same diameter as this one. So there we have, very faintly drawn in construction, outline of our pipe, and the height is 90 millimeters, so a third of that is 30 for me. So here is the total size pipe. I can draw that in. And let's put those center lines in because they will come in handy. The assessor will be looking for things like center lines. The assessor is looking to see that you understand what you're doing and understand principles of drawing. So there we have the start of our pattern. So we're going to develop just this portion out on this one, and we're going to develop it out flat in preparation for rolling up to make the real item. The next step is to divide these circles that we have here and here into 6 parts. We can do that by using our compass. We just simply step off around the circle in this fashion. We can use the 30-60 and achieve exactly the same results. And of course we need the center one. What we're going to do now is transfer those lines we've just drawn down to our drawing. And because we only need this portion here, we only need to do 1/4 of these, and they should meet up with these vertical ones coming down if we are drawing accurately. Right, so as you can see, we now have our lines coming down and crossing this V shape here. Right, let's identify what we are going to develop out. So it's this piece here, so here's the base, so we can carry that line all the way through, and here's the top, and we can carry that line all the way through. Now for my scale of 1 to 3, I've worked out that it needs to be 185.2. So I can just get 185.2 there. Take that up, double check, 185 and a bit. And bring that. Now this piece here is the total length of our pattern. Now we have to divide that into 12 parts. If we're just doing it for drawing purposes, we can take 1/12 of the circle, but because we are now going to manufacture an item, we have to be more accurate. So we are just going to do this method. Now this method is fantastic for doing any division, equal division of any number. So we're going to do 12 divisions. Now my total plane length is 185.26 blah blah blah. I've put that in the calculator. It works out about 15 millimeters. Now this isn't critical, but I'm going to take about 15 or 16 millimeters. There we go. So I've set my compass. I've put a random line up here. There is no specific angle for this line, and we're just going to step off 12 portions. 1, 2, 3. It is critical that I get my compass point in exactly the right spot. And there I have my 12 portions. Now this is the tricky magic bit. To divide this part here into 12 pieces, I simply take one set square, place at the bottom, allow the top one to slide, join up the last 2 points, so this point here and this point here. I've joined up those last 2 points, and now I just simply slide along. This is a much more accurate way of doing it than trying to step it off with dividers. You get quite quick at this. Do not take these down to this bottom line, because as you can see, this is on an angle, it's not square to the baseline. So now putting our T-square back in, we get it square to the baseline, and simply bring these lines from the top straight down, perpendicular to the base. Count that. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 sections. Now we're going to bring these points found here, and we're just going to take them across. Now 6B in the middle, we can put that there. We can do it either way, we can put it there or there, but we simply have to go either side of it. And back down again. And we have identified the points to form our arc. Using French curves, we can now join those points up, and with French curves, make sure 3 points are touching. And we can now fill in the straight lines. And there we have the pattern completed for this T-piece. Let's get onto the base. Now you can draw these separately, or you can put them both together on one piece of paper. I'm going to put them both together, and because I'm a wee bit lazy, I'm going to use some of the dimensions and lines from here and transfer them up. So we can transfer these up, and we need these points on the circles, so we can take those through as well. And with this, what we're simply doing is turning this item 90 degrees. So I can draw a line across here, and we know it was 110, so if I measure up 110, we will end up about here. Let's find the the middle of that. And we need to go 30 millimeters either side. And we need to go 30 millimeters up. Let's draw that in. Put those center lines in again so we know what we're doing. There we go. Now we've got our top view completed. We can draw our pattern. And we can use all of this from here, and we can just transfer that up to the pattern above because it's exactly the same size. So the pattern length is the same, and we have 12 equal pieces. This here is the total length of our pattern. Don't worry about these little squiggly lines in here, they don't count. Righto. So we have taken these points here and actually taken them all the way up to here. So here they are here. So we can take those across onto this drawing. Middle line. And now we're going to put the hole in. So this represents the hole. So we can simply either start in the middle. Here's number 6 up here. 6, 7, 8, 9, 10, 11, 12, 5, 4, 3, 2, 1, 0. And we can simply join the dots. So we can go in here, here, here. We've come to the middle, and we can start working our way back out again. That will give us a cutout on the end, similar to this drawing. And as a welder, this is the one we'd prefer because obviously there's less welding in. So let's join those up. And there we have it. So we'll draw the outline. So, as I said, if you do cut it out of the middle, that would make rolling up the item a wee bit easier. So the thicker the material, the more difficult it becomes to roll, so you might select to have your hole in the middle. So let's do that. I'll just use a different color so we can do this. Simple as this. Six, 8, 9. There we go, and let's do that. Put that in blue. It's exactly the same shape as what we've done on the ends, but we've simply moved it to the middle. Now the choice is yours whether you cut the hole in the middle or on the ends, but of course you only do one. So there we have it. These blue lines represent a hole in the middle, and these black ones represent a hole on each end. So there's our finished item, all done and dusted. Now you'll cut these out, sellotape them together, and present them to the assessor for marking. And there we have it. Unit Standard 25704, Task 1, the pattern development of 90-degree equal size pipe penetration.